Hello and welcome to the first of my series of mathematics videos. I will be covering all courses in the HSC from general to 4 unit, and I will also be covering specific courses from the University of Sydney, and I will be going through all content in those. 4 unit will be the main priority with videos from other courses coming through as they do, and the University of Sydney courses being uploaded once the 4 unit course has been done. This is because a lot of courses at the University of Sydney require or at least assume you've done 4 unit. And now let's move on to the first in the 4 unit videos, the ever useful and mysterious complex numbers. So, what are complex numbers? Well, complex numbers are defined as follows. They're the set of all x plus iy, such that x and y are both real numbers, with I specifically pertaining to the square root of -1. This is important as it allows us to solve many equations, especially quadratic equations, that were not previously possible. You know, the ones that had a negative discriminant and you were just told to write no solution for, or at least no solution in the real numbers for. Now you can write explicit solutions for them. Given a complex number z equals x plus iy, it can be said that the real part of z is equal to x. This is because x has no imaginary, or it has no I attached to it, whereas y does. That's why it can be said that the imaginary part of z is y. In fact, in order for any two complex numbers to be equal, both their real and imaginary components must also be equal. This comes from the fact that the complex numbers are not an ordered set. There is no one complex number greater than any other. This is because I does not have a numerical value. Now, let's get on to how we do operations with complex numbers. How do we exactly add to something that doesn't exist in the real numbers? It's easier than it sounds. When we add or subtract complex numbers, we treat them like algebraic terms in an equation, like you did in Year 7 maths. For example, so if z equals x plus iy and w equals a plus ib, then z plus w equals x plus a plus I outside of y plus b. And for subtraction, z minus w equals x minus a plus I outside of y minus b. It's simple as that. We just treat the imaginary terms and real terms as separate variables and collect like terms. However, multiplication is a little bit different. We treat it like a binomial expansion, rather than simply multiplying real and imaginary parts. So, this is just like, again, expanding a binomial expression. However, we have to remember that I squared is equal to -1. That's the only real complication when it comes to multiplication. So, if z equals x plus iy and w equals x plus ib, a plus ib, then what we do is we multiply all the terms in the first bracket by the terms in the second bracket. So we do x times a plus ixb plus iya plus I squared by. Now the I squared is important because remember that equals -1. So what we end up getting is xa plus ixb plus iya plus I squared yb. And then we go to xa plus ix plus I outside of xb plus ya minus yb. So, and then we just group the real and imaginary terms together, like you would with addition or subtraction. Division is a little more complicated, and we'll get to that in the next video, and that's where we will introduce the idea of a complex conjugate. I hope you enjoyed this video. It'll be first of many in this series.